Okay, so that's the big title. But I'll be talking about not really science. I'll be telling the story. Hopefully, um, you'll be not really bored for that. But number one, number two, at the end of the day, my main objective to be here just to make sure that are we really trying our best just to make sure that the people who are working all over the world, the basic science team who are going abroad and then working there, and they are becoming they are really contributing so much globally, but they do not have the opportunity to really contribute in this country because I mean they all are interested to do that, but unfortunately I could manage maybe some. So, but unfortunately, if we get all together, then possibly we can change the whole country, in fact. And I'm understanding this more and more with this COVID after this COVID time. So anyway, that's my title. It's a broken table. I'll be maybe showing you a little bit, but not really the true broken table. That was maybe 6 years later, photograph would be 6 years later, and state of the art microbiology lab that convenes, I mean, the subsequently. And my journey, the 4 decades, I don't know whether how much I could serve the society, but I could really work with a lot of people. And then I could not really be in touch with the people really who are my friends in the university time. Okay. So, sorry, you can start going. Okay. Somehow my slide is not moving. Oh, okay. Sorry. So, so if you could look at the preface, so myself and my background. So why really am I talking about myself? Because in fact, in disguise, I'm here to tell the autobiography of a mediocre. I'm sure that Jeva will be remembering mediocre student and biology faculty in the University of Dhaka. I mean, anyways, my daughter Sejuti wants to say that if really I call my Baba as a mediocre, that may be overestimation. He was really even below that. So, anyways, the Curtin Hall, 1976. That's the time when I really came to Curtin Hall. So I said, the Bangabandhu being University of Bangladesh. And we failed to get the entry in medical college. I did my best. My parents and the whole family. I think most of the people who were really in the biological science, they really tried once at least, or maybe twice. I did it twice, but I could not do that. And ultimately, I went to botany, but that was also biology. So I really was enjoying very much that also. But I also got involved with politics and then slogan and then writing the Chica, you know that the Chica. But at the same time, I got a class friend at that particular, almost on the first year. And she also helped me in study and also in politics in both the way. So moved to the Department of Microbiology, my beloved subject. And thanks to my teachers, in fact, Professor K.M.S. Aziz, Mahbub Rahman, um, and then Motiur Rahman sir, and Professor Anwarul Azim. That's the best. That's the main person, in fact, who really mentored us in microbiology. However, the politics continued, and it took 9 years, in fact, and that is the reason we spent 9 years, in fact, in the university. So that's possibly in one way good that we got good, very nice environment at that time, but not really very smooth on those days. So university was closed sine die in 83, and opened after several months. But in the meantime, my class friend converted to my better hub. So that's the way really my background is. And this was the almost the table where I was worked in 1983. And this was an oven. On the other side, in fact, that not in the picture, there was a burner to burn to detect the sugar. In fact, on those days, there's the boiling and then the sugar, things are getting colored. So, and that is the way, that's my place, in fact. That was a corridor, in fact. People was going behind with that place and coming, but that was my table. I had some a Bunsen burner and not really Bunsen burner, split lamp, and some glass plates. And my teachers on those days, in fact, including botany, biochemistry, they were always saying that they are extremely sympathetic. I was saying, don't worry, we'll be finding a job for you. So that's the way my life was going. So, but subsequently within 1985, we moved for my PhD, and we really had to go there. The reason, two of us, I mean, my parents were the only one condition to really join with us. That is the higher education. So at that time, quickly I got a scholarship from India, and I went to the Institute of Medical Science in Banaras University. So I did the basic science again, Campylobacter jejuni, animal model I prepared, and then a toxin purification, immunobiological relationship with other toxins, and what is the possibility of make a vaccine of that. So that was the plan, and submitted the thesis on the 9th May 1989. And my parents were thinking, in fact, that I should really go to somewhere else for higher education. But we really back to home on the 11th. So from 9th, we submitted the thesis. On the 11th of that month, we came to Bangladesh. And the next day, two of us went to the Doel Chapter just to see that again. But I shifted my gears, in fact, after coming to Dhaka Shishu Hospital. So I was in Shishu and I got the lead. Think about it, how powerful I was. I was only for 2 years and I got 4 years. But that's only because of the pediatricians. They were so convinced with my work. They said, okay, you have to come. So I got the that kind of leave. But I started the hardcore work in Institute of Medical Science in India. But coming back, you also tried to do that, but then thought, no, that's not the case. That ICDRB is there. And that's a short, in fact. I cannot really compete with the diarrheal disease with that. And I also thought that under 5 children are dying, and that's my responsibility to do something to help people, in fact. So that's the way I'm going to my field, in fact. So why the children are dying? The mainly pneumonia, meningitis, and typhoid, and some other infectious diseases as well. But there was no resources, zero. The first grant I got 25,000 taka, and I got some hand-carried disposables from Nagasaki University because I published one of my paper, small paper in the Lancet, and that really Nagasaki University professor was convinced. He just came with a big suitcase with all those disposables. That was the beginning, and at the time also I was in the corridor only. So what are the steps, in fact, for introducing a vaccine? Because I just wanted to, with this, there are multiple steps. In fact, if we really want to do something to really prevent the deaths. So the first is you have to generate the evidence. Next, convince the policymakers and donors, because you need to policy because they are convinced, and then the donors have to give the money because we cannot really buy the vaccines. And subsequently, the facilitating the introduction of vaccine. That's another important thing because you have to select which vaccine and then and measuring the impact also. That's also important, that is the impact. And then only you can convince your policymakers, yes, I can show the impact. So I can really, we'll really go for another vaccine. So first one was Haemophilus influenzae type B. And that Haemophilus influenzae type was very interesting. It is a very, very fastidious organism. And Bangladesh, India, Pakistan, all of them are saying, no, there is no HIB in this part of the world. So you don't need vaccine for that. And first thing I did, I started working on Haemophilus influenzae type B. And I showed that we have high number of Haemophilus influenzae and it is increasing gradually. That's the way it was being shown. And then also I showed that not only that, it is becoming multi-drug resistant. And you also see more and more multi-drug resistance, higher the deaths. So that's the way things were going. And that's really convincing, very, very convincing. And then what I did, but with this, because he was not there, everybody was talking about, a Johns Hopkins professor just came to me just to see, are you really getting hit? Can you show some? Because it is very difficult for them to believe, in fact. So I really did that. So I was really happy to meet that person. But unfortunately, when he came, I have one stool, and he came. He was really waiting to talk to me. So I said, okay, why sit down? And he was telling me, oh no, you sit down. Then both of us really were standing because we do not have another stool, in fact, for him. So that's the way the things were going, in fact, at our lab. So gradually it was increasing. I will be telling you how much we could do with all these. So then somehow BBC World invited me to give a talk on that. So it was really a documentary. So that documentary really was extremely helpful because advocacy was very important, number one, and PVC is overall international, and really convince the policymakers. Why? After all, we were ruled by British by about 200 years. So we still, anything from British is very, very good. So that's really my maybe more than my publications, more of this documentary helped a lot. And then we looked at, these are the Haemophilus type B. You can see the trend. But when we introduce the vaccine, then you can see how it has gone down. So that was simple. That's not really high-tech science, but that's only that what we want to do and how we can convince the people and policymakers and how we can really save the lives. And finally, till now, we just can calculate that every year we are preventing 3,100 deaths. At the same time, remember, this vaccine was introduced in US in 1989. That means 20 years before. What a shame. But we could have evidence before. We could have get the vaccine before. That is very important. Okay, going next. Other organism, my most favorite organism, Streptococcus pneumoniae. So this is an organism. It has many different serotypes, about 100 serotypes. And you cannot really have a conjugate vaccine with many, many serotypes. Until now, we have 20 different serotypes. We can really conjugate it, not really more yet. So, and at that time, when we really started working on this, that was only 7-valent vaccine. Let me tell you, vaccine was not there at that time in the 1990s and also in 1997 around. So people were making the formula on their own. And I looked at this and I found, my dear, there are only 3 or 4 laboratories in the world who are really doing the serotyping of Streptococcus pneumoniae. I worked with a British person, and then he was very convinced with how we really helped him and helped him to understand the typhoid disease. And he was so convinced Then he said, okay, I want to give a consultancy. So he gave me 50,000 taka. And 50,000 taka on those days in 90 was a very big money. I said, I don't need the money. I need the antisera to serotype the Streptococcus pneumoniae. And that's the way I get the serotype. And that's the time I started serotyping. Otherwise, serotyping was only done 3 or 4 best labs in the world. So with this antisera, I really did this work. And then I could really publish it in Journal of Clinical Microbiology. And I showed one thing, that all these are not really very much goes with Bangladesh or maybe this part of the world. So we call it Dhaka 9, and clinical microbiology really accepted that, the Dhaka 9. And you can see the newer serotypes are there here. And all those serotypes are included. And that is the way I got now 10-valent vaccine, and that vaccine introduced in Bangladesh. And then, and look at this. The one other important thing is that Bangladesh has many different serotypes, 59 different serotypes causing invasive disease. And that is the reason our coverage is not really very high. 47 if it is 10-valent, 53 it is if it is 13-valent. So, but that's okay. If we can really save 50%, that will be also great. So advocacy is very important. So I really could accommodate a lot of people with the talk at BBC World, and then at the same time I gave a talk in the British Parliament as well, just to tell that how important the pneumococcus is. And then for advocacy, I invited British parliamentarians. You can also see who is really talking, that British parliamentarian. And we also have Julfikar Bhutta. He was there in AKU in Pakistan. He also came, and also another 15 other people from different countries. All of them came, and we had rally, in fact, all over the city, just to make sure that people are really getting excited. So it was huge people, in fact. And Savarashan Chaudhary, you can see, and a few other parliament members as well, who really mentioned that one of the boy of this country is giving a talk in the parliament, but our parliament even doesn't know how. So that's the way he said, we have to have this vaccine. That's the way the pneumococcal vaccine came, in fact. Okay, so, oh, what's happening? Okay. So, and that was the pneumococcus. At this point, we really introduced the vaccine. And then you can see after the introduction of vaccine, all severe pneumonia cases has gone down significantly. So all those are, so that is the reason I should say that the basic science team, they nature, then science, but my papers are not really in very high impact, maybe maximum, maybe 10. I have few in Lancet and other MBio and all those, but not really other high. But I also try to convince my clients. Who are my clients? My clients are mainly the pediatricians, because I have to convince them, then only they will be working with us. Then only they will be sending me the specimens and everything. So that's the way it really went. But in the meantime, we really changed ourselves, in fact, because we thought that Shishu Hospital, I may not stay here for all the time. So we really changed. We added Childhood Research Foundation in 2007, not really 17. We thought about this and we put it together. And this was the group, in fact. You have all of them are pediatricians other than me, in fact. And you know the Professor Naila, you know Professor Ruhul Amin, Professor Shams Arifin of ICDRB, Professor Naushad, Professor Hanif, all those are this. And at the same time, we also expanded our overall, our range, in fact. So in addition to Dhaka Shishu Hospital, we moved to another 4 hospitals. So Chittagong Mao Shishu Hospital, uh, AMR Shishu Hospital, and also Dhaka Shishu Hospital. So all these 4 hospitals are there. And we have our, and you can see this is Dhaka Shishu, these are Kumudini Hospital, and Chittagong Mao Shishu Hospital and Dhaka Shishu Hospital. And all these places, we have our own lab. We have built the infrastructure there. We put our own people there, own microbiologists, own biochemist, all people are there. You go to Mirzapur, you'll see a very big lab, maybe like Popular Diagnostic Center, that lab. And that we have biochemistry, we have microbiology, all people are there. Okay, and then we have in Mirzapur, we have a population-based site of 63 kilometers and 70,000 households. Each and every household are being visited by the community health workers just to check the under 5 children. And those under 5 children, if they're sick, they're coming to the outpatient department of Kumudini Hospital. That outpatient department structured, built by us. So, and each and every under 5 smart card has a smart card, each and every under 5 children. And that card, once they're coming there, they just scan in that outpatient department, and they will see it's going to the computer where the doctors are sitting, in fact, all Child Research Foundation doctors, in fact. And then also, each and every household you can see, and all these sites are supported by WHO. And these team members and WHO really in 150 labs, countries are there where this kind of networks are there. And Bangladesh was in that particular year, in 2016, in Menit lab, in fact, or best field site. So that's the way really we are moving. One other person, what Jeva was talking about, the ANISA project. ANISA project was the largest neonatal project in the world. That project was really have huge amount of funding, and you can see it was managed by Child Research Foundation, but you can see how many people I got involved with this. Center for Disease Control Atlanta, University of Toronto, ICDDRB, Oxford University, WHO, and Bangladesh sites are Bangladesh Select, India in Shibgor, for a different one now, and Bangladesh Aga Khan University. All those are there. And that's the way really we started ANISA project. And it is really now the biggest work. And we just published the first paper in the Lancet, but other papers are going on, in fact. And those are the places where we are now working even. Those are the sites where we work for this, but also now we are working in Delhi, Lucknow, Patna, Rourkela, Pune, Vellore, because WHO and Gates Foundation sometimes ask us to go there, mainly any pneumococcal work. They will be sending us, they show me you have to oversee that. So you'll be visiting them. Okay. So we are there, what should you say? We really look at, oversee them, in fact, their work. So we are funded differently, and they are funded by their own from Bill Gates. So the limitation of surveillance. The limitation of surveillance is when we go to the health, then it is a very big problem. The reason, there are many specimens we are getting. We do not get any etiology, but we can see the pus, we can see the baby is very sick, and each and every signs are there, but still we are not getting any etiology. Number one, many of them are coming with antibiotic. Number two, we don't know many of the etiologies, and maybe we don't know that etiology is causing going to the blood or not, going to the brain or not. So those are important things. So what we did, I really do not know because when, I don't know, Jeva will remember, I don't know whether our time we had the PCR. I believe no. I never saw PCR, in fact, in Dhaka Shishu Hospital. I got PCR after a long, long time. But now we are doing sequencing, metagenomic. So, but I was biobanking. I was always preserving all those specimens who are not really, who are really, really uh, getting the specimen from the brain, or maybe from the blood or from a lung. We are preserving all those just to make sure that uh, some point maybe we'll be getting something by which we'll be discovering what is there. So for that, Shejuti mainly tried her best to different countries whether we can really find something, because in the meningitis cases, we are getting meningitis, we are getting numerous cell, but no etiology. So then she really convinced, worked with the Chen Zuckerberg BioHub and together with the Gates Foundation. And then she worked to San Francisco, in fact, just to understand what is going on with them, how they are doing metagenomic. And she started working on it. And in that case, and I also preserved from this maybe in 200 at that time, that year, we are preserving all those specimens and also the very sterile cerebrospinal fluid, absolute sterile. And then also the water that also we collected, that control. And with all these control, we saw that everything we saw positive, exactly when we did the metagenomic, the results are perfect. We can see the most in Pneumococcus, Klebsiella, E. coli, and all those, and Neisseria meningitis. And then here we put the controls. There was nothing positive. That's interesting. But when we really put the specimens where we could not get anything, we just tried with the first time, we just tried the small number because we do not want to do invaluable specimens. So look at this. We got very, very interesting. We got enterovirus. We got mumps. We got chikungunya in the brain. None in the world was knowing that chikungunya can go this much. One possibly case report was there that chikungunya was found, but that was only not really this way. That's really suspicion that was the case of chikungunya. So that's the way chikungunya we got. But then we really matched that it was the chikungunya time or with Bangladesh. So whatever you do, that cannot be done in the lab anyway. So that's useless, in fact, for the main people or for the patient. So immediately we designed the primers just to make sure that whether we can detect chikungunya, and that can be detected even from the CSF. And then we really tested all our chikungunya time CSF specimens. And we could see that's a huge number of chikungunya on those cases. We all talk about why so many CSF specimens and we are not getting anything. Then we could understand those are the chikungunya. So that's the way we are really making progress. So this is just chikungunya. Okay. So, so in addition to the work, so with the addition of the newer team members, they're also doing some basic science. So azithromycin resistant, we are not knowing that azithromycin resistant was there in typhoid, but gradually we can see that you can see how it is increasing. But then nobody was knowing where that really, from where it is coming, where the mutation, and what is the mechanism. So, but gradually we are getting the sequencing machine, because based on that chikungunya, Gates Foundation got the Grand Challenge grant we got. And from there, we got the sequencing machine. And then we started to work on that. And then we can see the at specific places in all resistant strains, we can see a specific sequence. So that thought that could be the case, in fact, why it is only in the resistant strains, but it is not really confirmed. So, and then what they did, the mutation place was really incorporated in E. coli, sensitive E. coli, and sensitive typhoid. And then we found that they turned to be resistant. So that's the way confirmed that yes, genetically we can prove this is the reason the azithromycin resistant are happening. And then we can see all over the world now, all over the world now the resistance are resistant. Oh my dear, resistant strains are happening, going all over the world. And then, but that's again not very useful. People cannot really detect this and that where the azithromycin resistant is there. So we really do the mismatch amplification mutation assay, and by that we proved that we can also do it very simple way by the band, and also it can be detected anytime. So that's the way we can also bring it. And based on this, we really got the big sequencing machine, the latest sequencing machine to do the unknown etiology using metagenomics. So, and next phase are the pediatric disease observatory. So, and that is really from Gates Foundation. Sorry. Okay. And now it is named as CHRF Infection Observatory. All bacterial genome and bacterial genome will be sequenced by this. So, but coming back to this, how these resources, how we got the resources, in fact, because we have extremely limited resources. And in Bangladesh, all the limited resources are being improperly or inadequately used. So we are not really poor, not at all. And that is the reason, the lack of evidence. And if you have lack of evidence, then you will not really always remain with limited resources. But if you use it optimally, then you'll be really using the generation of evidence, and then you'll be getting the optimum resources as well. So that will change the vicious cycle, a virtuous cycle, but this vicious cycle is now gone. And by that time, this 2010 to 2021, with all these system, people really got funded us, Gates, WHO, Johns Hopkins, all those many other people really funded us. That's the way it's going. However, the corona, this is the chapter, and this is the sad part. It is really not science. This is more like our life, our young generation, basic science, university students. What are they doing and what are they achieving, in fact? That's my most important part, in fact, and that is the reason I'm here. So COVID-19, Bangladesh started with only IDCR. And sometimes we were hearing that only that one part can be done. But now we have 200 laboratories. From where these 200 laboratories are coming? Who really established these RT-PCR cases? And Child Research Foundation was the first non-government person, in fact, maybe second or third lab to do this, because even from the ministry, they asked that why are you not using your lab? So that's the way we started. But we are still giving it free of cost to the government, and we started with free, and still we are giving all the tests free. We have more than many thousand tests we did, in fact. So I really deleted the wrong one. Sorry. Okay. So this was the sequencing phylogenetic. So this is not 150. This is about maybe more than 800 sequence we did, about 900. And this picture was also more updated. Sorry. Tanmoy really gave this picture. I'm sorry, Tanmoy, I could not really put your slide. I deleted the wrong one. Okay. So COVID-19 is a challenge. The doctors did their best, but the children are dying, or people are dying, but gradually they learn everything. However, the science of microbiologists and biochemists are really missing at the hospital laboratories. Those are shame, in fact. So, and challenge. So it was a big challenge to multiple reasons. But setting up of the RT-PCR, biosafety hood, all those are important. And those that only can be done by the basic science team. But they were nowhere, in fact. So training of young laboratory personnel process based interpret the data, in fact. All these need huge human resources. Our hospital had limited number of personnel because we are not, there is no another Shomir or another, I mean, because none of them are really allowed. I don't know how I really established myself there. So now IDCR, DG Health, ICCDRB, CHRF, Child Research Foundation, World Bank, USAID, FAO, WHO, all of them together, all of us together, we just convinced that we should have the university students and decided to communicate with the university graduates. And we engaged, in fact, more than 40 members to different universities, in fact, and mostly PhDs. So oriented the team for ICDRB, IDCR, and WHO and FAO. In the first visit, they looked for the gaps. They really helped to improve, and they visited several times later. But always remember, a diverse team outperform a high-performing homogeneous team always. And that's the way, that's really published a very nice paper on that, in fact. So COVID-19, these university experts, in fact, um, worked together with a medical microbiologist. We call us the clinical microbiologist and the doctor who are really medical, they're medical microbiologists. But we have our own expertise. We work together, that will be the winning situation, in fact. So the barriers of collaboration. Why we cannot collaborate? One, the medical graduates, though wanted to be a doctor, they also want to reserve the clinical laboratory. Another one, the university graduates are not interested in the field of clinical biology, which is very true, my dear. I know it because I now get a lot of students from, I have about now maybe 15 or more than 15 medical graduates from different university, biochemistry, statistician, microbiology, and also the IT team also from the universities. All of them are coming to us. But all those days, it was very difficult for them. Only very, very poor students were coming. And now we get very, very high level students, in fact. And from English school also, they are coming. They're coming from England. They did their PhD and they're coming back, in fact. So, okay, great. So why they are not coming? They thought that opportunity is scarce, my dear. If you say that my opportunity is scarce, I think we have to fight. That's the way I went. I got demoted at my hospital. I left. My job was gone. Just they said your position is vacuum now. You are not there anymore. My dear, I went to the court and I sued the secretary and the director of the health, director of Shishu. I did that. So we have to someone has to really take those steps. And the clinical biology is only the medical graduates, in fact. So anyway, the most important barrier, the rules. The rule says the advertisement will never go in the name of the university students, unfortunately, because there is no opportunity. We all are very powerful in many ways. And if we are together, we really want to help because we know now how fragile the health system is in this country. So I really want to plead to my teachers, the policy makers, the teachers who are really very important, the university teachers. They all can go and really talk to them. And our students are now there in the I mean, what should we say? The big building. Anyways, the big building where we ministers are there, also there, all of them. So those policymakers are important, but most of the policymakers are coming from the universities, right? So we can really should work on this. So And my professorship is an exception, in fact, but we have to take that example. It's not failure, in fact, right? I didn't fail. So the double-edged sword, in fact, is a challenge because the BSc Science, MSc, PhD, most postgraduates are reluctant to work and limited opportunities and no career path. And regulations of the government, that's also very important. It's a very big problem. Let me give you some example. Akhtaruzzaman Mullah, soil science. He is such a great person. Is he not a clinician? Is he not really? Uh, how many? Um, I should say FDA approved uh, medicine he is having, and he really has the patent, and he is happy, happy, and happy, retired and happy, right? And he is really saving the lives. So who is more important? Just one degree, or maybe together only that will be win-win situation. The one other person, even Ghulam Murshid, was from Botany, and he was the clinical professor, in fact, and British clinical professor in British Columbia. Think about this: national expert in syphilis, Helicobacter pylori, expert in the complex serology, immunology in United, in the Vancouver, in fact. So, and Akhtar Hussain, my dear, I read it, and he was really working at the place where all the peptide work he's doing and developing the peptide-based therapeutics. And all in all, it seems that Dr. Akhtar will be controlling all mechanism of our body. As he did, he really controlled the constipation and also the hungriness. He will be really making the all fat people maybe slim. I believe that, all the best, but who is the clinician? Tell me, who is really helping the clinicians? Who is really saving the lives? And then we go even the younger one, the Rubaiyat Hassan. The Rubaiyat is a clinical molecular microbiologist in the department of pathology. What else you need? Why Bangladesh cannot get it? Tell me why. And before that, he was laboratory scientist at microbiology and virology lab of British Columbia and Children's and Women's Hospital. If he can be there, then why not we? And then if you say, okay, they are eligible, maybe we are not, but give us. I'm one of the mediocre. Think about the people who are really listening to me. They are really much higher. I don't know how much higher they are. I cannot walk that much. My shoulder has some problems. I really cannot look that high, in fact, honestly. So, but still, I proved that I got UNESCO award. I got ASM award. I got even, okay, those are the things, maybe I got it, but this is also from Bangladesh government, in fact. But remember, when I got the ASM award, when I got the phone call, the secretary of ASM called me. Okay, can you send your healthcare insurance card? I said, insurance card? I don't have it. I'm not an US person. Oh, sorry. Then it is a wrong. It is a wrong call or something. Okay. Then the president had to call me. Sorry. This time we got the Bangladeshi person, so she was not knowing that. So that's the way it goes, in fact. But anyways, so we learned the lesson, and our health system can be improved by the combination of medical microbiologist and clinical microbiologist. Otherwise, we are not going to happen, in fact. So, and nobody will be giving you. Nobody really gives it. We have to get it. And I really hope that we have all the strength. We proved it. All our friends who are abroad, they should come and really talk, make a conference, and we'll inviting all our if possible, if not the Prime Minister, will be being the Health Minister, will be being other ministers, will be spending few 100,000 taka, or we can even more. We can spending we will go to Shwanarga Hotel, bringing them, and let's talk what we do, and let's see how much because Prime Minister every time saying we need science, and they have given this time 100 koti taka, my dear, and I'm part of that, in fact. But I never said that. I said, ask my team, don't apply, because I don't want to take that. So that's the way. Anyways, thank you so much. I don't know how much bored you are, but I'm really, it's my passion and I love it, in fact. And I believe all of you are so important, so high, you can really help us. So, and then finally, then one person, one stool, half a table converted to this team. And this team only in the lab team, in fact. I have 150 people in my field. So you can understand how many people I'm dealing with. And thank you so much. Thank you for your patient hearing. Thank you.